Hello viewers, you are welcome to Catalyst Achievers Academy. Welcome to the first edition of our lecture, which is always the introduction to chemistry. It is very interesting and form the foundation of what? Chemistry. So this is very important. We are going to be starting the topic one by one because you need the foundation first. From the known to the unknown, we go. So, but before I continue, I want to urge you to make sure you subscribe to our YouTube channel, and then our Facebook and Instagram, we are also there. Locate us and they follow all our tutorials. And if you have questions to ask, feel free to ask your question. We are always ready to answer you. We now start with the first topic of the day, which is what? Atoms, elements, molecules, and compounds. This is very important. That's why we are going to start from this place, such that even if you don't have chemistry knowledge, if you follow all our topics, you are going to be grounded very well. We promise you that. We are starting this sequentially from atoms. So we now begin from atoms. Now, what is an atom? An atom is the smallest particle of an element which can take part in chemical reaction. Example of an atom is sodium atom. Sodium. What I wrote here is the symbol of sodium because some of these atoms, their name was derived from their Latin equivalent. For example, sodium was derived from the Latin word called natrium. Natrium. We now use the symbol Na as the symbol of what? Sodium atom. There are many. Even the atom of what? Potassium. Potassium was derived from the word kalium. Kalium. We now take the symbol here as potassium atom. So please, as we proceed, we are going to be analyzing this one by one. Repeat again, an atom is the smallest particle of an element which can take part in chemical reaction. And we have made mention of sodium atom. We also have potassium atom. We also have magnesium atom, and so on and so forth. As we proceed, we are going to be seeing different atoms and the compounds they form. Now look at element. What is an element? An element is the smallest particle of a substance which cannot be broken down into simpler units or simpler form. Example of an element is, I still use magnesium as an element. There is no way you can break magnesium as an element into a simpler form. So an element is the smallest particle of a substance which cannot be broken to any simpler form by an ordinary chemical reaction. Further examples of elements are, like I said before, magnesium is there, sodium is also an element, and then chlorine is an element, but a non-metallic element. Remember, in this element, there are metals and what? Non-metals. Metals are those ones that can always lose electrons, but non-metals are always gaining electrons. However, all of them are elements. Now, an element can also exist or form an ion. It can only form, let us take for instance, in this formation of ion, let us use sodium and chlorine to explain this ion very well. If you look at the atomic number of sodium, which we are going to explain further as we proceed, you discover that sodium, the atomic number is 11. And if you break this 11 into what is called duplet and octet structure, please note that duplet means 2, octet means what? 8. Now we have sodium and the atomic number is 11. If you try to break this 11, we have 2, 8, 1. Therefore, the valency of sodium is what? 1. The valency of sodium is the outermost electron. And that's why if you look at the ion, sodium can always or can only lose this one electron, which is the valence electron. Please note that for an element to form an ion, it can only lose its what? Valency, which is the combining power of an element. So from this, the valency of sodium is 1. That is why when sodium loses this one electron, it becomes sodium plus. Please, that plus means plus 1. But this one here is what? Invisible. Note that, please. So if you also check chlorine, the atomic number of chlorine is 17. And if you break, I have 2, 8, and 7. For non-metal, how to get their valency is this. What can you add to this 7 here to make it 8? One can think that, as I have in sodium, that this outermost electron is the valency of sodium. If you come here again and say that because of the outermost electron being 7, that the valency of sodium is 7, you are wrong. For non-metal, how to get their valency is, what is the number I'm going to add to the outermost electron to make it 8? And that is 1. That's why the valency of chlorine is what? 1. And not what? And not 7. Now, we have now established that the valency of Cl, that's chlorine, is 1, and sodium, the valency of chlorine is 1. Now, when they undergo chemical bonding, I want to illustrate this with a diagram. Now, for sodium 281, if you draw it according to the Kl shell, the first shell will carry 2, and that will have 1, 2 electrons. Second shell will carry this 8 electron, that's 1, 2, 3, 4, 5, 6, 7, 8. So the last one is the last shell. We carry what? This last electron. That's what? Chlorine. That's the sodium. Now this is sodium, please. Let me write this here. This is sodium. When it's combined with chlorine, which is 287, the first shell we carry 1, 2. Second shell we carry 1, 2, 3, 4, 5, 6, 7, and what? 8. Then what remains is what? The last shell. And that last shell we carry 1, 2, 3, 4, 5, 6, 7. This is the last shell. This thing I just demonstrate here, you can also write it in a short form by doing it this way. For chlorine, I can now put it as 2, 8. This 2 is this electron, this 8 is this one here, then this last electron I can now put it here. That is the shorter form to save your stress. Then we also have this sodium. I can write this sodium as chlorine. This chlorine. This is sodium. This. Then for chlorine, I can write 2, 8. Then I have 1, 2, 3, 4. Let me also refer you back to this place. This sodium here needs extra 7 electrons to attain octet structure. But this chlorine here needs only 1 electron to attain this word octet structure. Therefore, sodium will prefer to lose this electron to what? Chlorine. And when it loses this electron, it will lose this shell. And then I will have what now? Sodium ion like this. 1, 2, 3, 4, 5, 6, 7, 8. Something like this. Completely what? Filled. Because sodium have lost 1 electron, it is now written as what? Sodium plus. This plus shows that this sodium has what? Removed this electron. And it has formed a sodium ion, as you can see here. Now, this chlorine will gain this electron, and what you now get here as chlorine ion will now become plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Chlorine has become fully filled and therefore become what? Cl minus. This minus means it has gained extra 1 electron and therefore to form Cl minus. In summary, ions are formed when an element or atom loses or gains electron. If you at the end, this sodium and the chlorine, when they now combine as a normal salt, which you normally use at home to eat, the sodium chloride you use at your house to eat is this sodium chloride, you will discover that I have sodium ion and the Cl minus, such that this minus and this plus will do what? Cancel out. And at the end I have what? Sodium chloride. That is why it is neutral, because the negative sign will cancel the positive sign. So finally, you can now see that every atom you see, if you want to analyze atoms structurally, every atom contains electrons revolving around a specific area called the shell. So every atom contains 2 or more electrons that revolve around the shell. So whenever you talk about atom, structurally, you always imagine an atom with an electron revolving around it. Okay. All right. Let us look at elements. Very, very important. Now, elements. An element can be defined as the smallest particle of a substance which cannot be split into simpler form by ordinary chemical reaction. A very good example is sodium as an element, magnesium as an element. There is no way you can split magnesium as an element into simpler form. Remember that these are not the only elements we have. We have up to 108 or 109 elements in the periodic table. Okay, so please remember this is not the only element we have. Now, if I ask you what is the symbol of element called gold? Gold. Am I going to write G as the symbol of gold as an element? No. Like I said before, some of these elements, their name was derived from their Latin equivalent. Now, we now look at the concept of molecules. So, there are some substances that we prefer to be in combined state. These elements, they prefer to combine with either itself or with another element. When such element combine with either itself or with another element, they form what is called molecules. Therefore, molecule can be defined as the smallest particle of a substance which can exist alone and the chemical property of that substance. Remember, the various atoms that are combining to form molecules, they fit each in a simple whole number. They always combine in a fixed ratio. For example, if I have hydrogen combining with oxygen to form water molecule, you will discover that here I have, in this one molecule of water, I have 2 atoms of hydrogen and 1 atom of oxygen combining to form 1 molecule of water. How many hydrogen do I have here? 1, 2. I have what? 2 hydrogen. How many oxygen are here? Is here? 1. So the combining ratio of hydrogen and oxygen in water is 2:1. You discover that the elements or the atoms combining to form molecules, they combine in a fixed ratio. And these fixed ratios are always in simple whole number ratio. Now let us now look at the compound. When 2 or more elements combine together, they form what is called compounds. Therefore, sodium chloride is an example of compound that is formed when one atom of sodium combines with one atom of chlorine. So a compound is made up of two or more atoms that combine chemically. Now, since a compound is made up of two or more substances chemically combined, remember also there is what is called mixture. Now, what is a mixture? A mixture is two or more substances that are combined. But please, there is a difference between a mixture and a compound. In compound, it is always chemically what? Combined. But mixtures are not chemically combined. Mixtures can be separated by physical means, but compound can only be what? Separated by chemical means. Now, the sum of the property of mixture is equal to the sum of the individual property. For example, if you look at rice and sand as a mixture, you will discover that even when you separate the sand from the rice, the property of the rice remains the same, and then the sand property also remains the same. But once you have compound, once they combine, the property of the compound cannot be equal to the property of the individual elements that combine to form the compound. Now, another example of mixture, which all of us know well, is air. By definition, we define air as the mixture of gases. So air is a mixture that contains oxygen, nitrogen, then we also have what? Carbon dioxide and the noble gases. These are different. Let us now look at the concept of radicals. It is very, very important because very soon we shall be entering into formula of compounds. Before you now talk about formula of compound, you must know what is radicals and their valency. Please review, my fellow viewers, please make sure you grab this aspect. It is very important, both in stoichiometry and the balancing of chemical equation. This is what the basics. So I want to establish the concept of radicals. Now, what are radicals? They are a group of atoms that come together to behave as one. They are always a group of atoms that come together to behave as one. You cannot separate them. Now, I want us to look at the first radical, which is what? OH radical. This OH is called hydroxyl radical. And it always has what? Minus sign. And that minus means that the valency of OH is what? 1. So please, I want you to try to memorize the valency of these radicals. It's important in writing the any compound. Now, another radical we have to look at is what is called CO3 radical. We call it trioxocarbonate radical. In chemistry, 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, and so on and so forth. Now, in a compound, if you want to pronounce oxygen in a compound, call it oxo. So this is called trioxocarbonate radical. And the valency of this radical is 2. We also have another one, SO4, 2 minus. This is called tetraoxosulfate radical. And the valency is also 2. Please remember to master the valency of these radicals. It is very important. We also have another one called SO3, 2 minus. So this is what? Trioxosulfate radical. And its valency is equal to what? 2. We also have another one, NO3 minus. This is what? Trioxonitrate radical. And the valency is what? 1. We also have another one, PO4 3 minus. We call it what? Tetraoxophosphate. And the valency is equal to what? 3. Notice it is important you note that the valency and the charge they have is what? The same. The only difference is what? This charge you are seeing here is called their oxidation state. So it is equal to what? Its valency. But the difference is the what? The charge. The minus and the plus sign. Please, it is important. Now, these are some of the radicals you should know and their valency. Once again, this is what? Hydroxy radical. The valency is 1. This trioxocarbonate radical. The valency is 2. This tetraoxosulfate radical. The valency is 2. This trioxocarbonate radical. The valency is 2. Trioxonitrate radical. The valency is 1. Tetraoxophosphate radical. The valency is what? 3. Now, if you now want to write the formula of sodium trioxocarbonate, let us look at how to write the formula of sodium trioxocarbonate. Sodium trioxocarbonate contains sodium and the trioxocarbonate radical. How do we write the formula? I will tell you 2 ways to write it. It is very important. Don't cram chemistry. Understand chemistry, because chemistry is science. Alright? Now, as we mentioned earlier, members of group 1 element has 1 valency. How? If you look at the members of group 1 that contain sodium, potassium, and so on and so forth, if you look at the outermost electron, they always have 1 electron, telling you that their valency is what? 1. Also, if you look at that outermost electron, they end in 1, telling you that the group is what? 1. So the group which an element belongs to is also determined by the outermost electron. So if I write for sodium, I will be having for sodium atomic number is 11. So I have 281. So this one is what? The valency of sodium. And also sodium belongs to group what? 1. So that means the valency of sodium is 1. There will be exchange of valency in this what? Compound. Sodium will exchange the valency of 1 to trioxocarbonate, and then trioxocarbonate, what is its valency? 2. Can you see it? 2. So they will now exchange. Trioxocarbonate will give its valence to what? Sodium. At the end, you have what? Sodium. Then this 2 will go here. I have 2. I have CO3. This one here is for trioxocarbonate radical, not only for oxygen, not only for carbon, but what? Trioxocarbonate radical. This one is for them. So I will put it here. But in chemistry, you don't write 1. So there is no need to put this one. Therefore, the formula is what? Sodium 2 CO3. This is correct formula of sodium trioxocarbonate. Alright, this is the first way to write the formula, but there is another way to write this formula. I want to write sodium carbonate, sodium trioxocarbonate, CO3. Please, what is the charge of sodium? It is what? Plus. Sodium is always plus 1. Trioxocarbonate, the charge is always what? 2 minus. Now, this is a salt, sodium trioxocarbonate, and it must be neutral. And for it to be neutral, all the charges must cancel out. Now, I have plus here, and I have 2 minus here. So for me to cancel this plus and minus to have a neutral charge, I will need 2 sodium to be able to cancel this 2 minus. Please, this thing is like this. Sodium plus. Then this was CO3. This 2 minus, allow me to write it this way, minus and minus, to show it is what? 2 minus. Minus and minus. Now, if this plus cancel this minus, I still have what? Minus sign here. This is not neutral. So for me to have neutral, I will need 2 plus to cancel this 2 minus. Now, so I will need what? Sodium plus, and then another sodium again plus, to be able to cancel CO3 minus and minus, such that this plus will cancel this minus, and this plus will also what? Cancel this minus. So that at the end, so now if this plus we combine with this minus and they will do what? Cancel out. Now this minus also will combine with this plus and do what? And they cancel out. At the end of the day, you discover that for you to form a neutral compound from sodium and triosocarbonate, you will need to have 2 atoms of what? Sodium to combine with triosocarbonate. Because what you need is 2 atoms. 1, 2. So I have what now? Sodium 2. Why? Because I have 1, 2. And what now? 1 triosocarbonate. So I have CO3. This formula is also the same thing with what? This formula. Let us use another compound as an example. For example, calcium tetraoxophosphate. That is calcium tetraoxophosphate, PO4. Calcium, the charge in calcium is what? 2 plus. Tetraoxophosphate, as a radical, the valency is what? 3. So I have what? I have 3 minus. So before you form a compound, there is exchange of valency. So calcium will give its valency to what? Tetraoxophosphate, and tetraoxophosphate will give its valency to what? To calcium. Okay? So at the end of the day, I'm going to form Ca. This 3 here will go this place, and I have Ca3. Then I will also have this 3. Okay, sorry. Okay, yes. And then I will also have at the end, yes, Ca3. And then I have what? PO4. Now, this 2 is for this PO4. But this 2 here is for tetraoxophosphate as a radical, and not only for oxygen or for phosphorus alone. Because this 2 is for all of them, you have to do what? Put it in a what? A bracket to show that the 2 is for tetraoxophosphate radical. So the correct formula of calcium tetraoxophosphate is Ca3. I have PO4. Then I have what? 2. This is the correct formula. This is just the tip of an iceberg. What you are seeing here is just a small package of the full thing. When we are now coming in our next class, we are now going to see in details these elements and compound and how they are formed. Please make sure you subscribe with us. In our next topic now, we are going to be looking at nomenclature of these compounds in full. Now, that is when we are going to discuss this thing I just said now in details. So please, we assure you that if you continue this class with us, there is no need to panic. I'm assuring you that your jam is going to be what? One sitting. Remember, we know the secret to make it once. Make sure you subscribe with us.